Okay, so for this one, we're now going to talk about how to solve log equations where there are logs on both sides. So with this one, that's different from the logs on one side is everything in the problem is going to have the word log on it. Every part of the problem will have the word log. So that's kind of the indicator that says it's going to be this type. Now, what's going to happen is you are going to need to condense one or both sides down into a single log, okay? So very similar to the rule that we had with the exponentials where they had the same base, and we get rid of that and just look at the exponents. We have a similar rule in logs. We have log base b of m equals log base b of n. We can get rid of the log base b part, and we have m equals n. Another reminder here, always check your solutions. Remember that you can't take the log of negative, but you can have negative answers, and you also can't take the log of 0. So that doesn't take 0 out. You just kind of need to make sure that you're watching those, okay? And then as another example in this one, we're going to talk about revisiting the compound interest formula because we now have a way to do a little bit more solving in that type of problem. So we're going to start with this one, okay? So we're going to do natural log of x minus 3 equals natural log of 7x minus 23 minus natural log of x plus 1. Stop share. And I got a little far on my board, but it's okay. So now this side already has a single log by itself. So I don't need to do anything over here. But what I do need to do over here is I need to condense. So we think back to our product, quotient, and power rules. I have subtraction, so that goes back to a quotient. So I'm going to have natural log of x minus 3, natural log of 7x minus 23 over x plus 1, okay? And all of that is in one fraction. Remember that when you condense, you should have less log words, okay? So now I've got natural log and natural log on the front ends, but they're singletons, so I can get rid of them. So now I have x minus 3 equals 7x minus 23 over x plus 1. Now, the first thing that I'm going to want to do is multiply this x plus 1 back over here to the other side. So I'm going to have x plus 1 times that x minus 3 equals 7x minus 23. Okay. You could also write a times x plus 1 factor on each side if you'd like. This side I need to distribute, FOIL, however you want to call it. Going to do some combining here in the middle. So I've got x squared minus 2x minus 3, 7x minus 23. I am going to want to get all of this combined over to the other side. Okay, I'm going to want to get this, excuse me, my camera flipped there for a second. I'm going to need to get this combined over to one side. So I'm going to subtract the 7x and add the 23. Subtract the 7x and add the 23. It's going to be plus 20 equals 0. Again, looking very quadratic-ish here now, so you can use whatever technique you like now. I'm going to factor. And again, you can use whatever technique you like. Go back and look at section 1.5 videos to see those options and those techniques that you have. So again, I'm now going to set each piece equal to 0. So I'm going to add 5. Add the 4. So we're going to check, okay, and see what's going to work here. So if I take 5, 5 minus 3 is 2. So log of 2, or natural log of 2, that's okay. 7 times 5 is 35. 35 minus 23 is 12. Natural log of 12 is 5. 5 plus 1 is 6, so that's okay. So we'll keep this one. 4 minus 3 is 1. That's okay. 7 times 4 is 28. Minus 23 is 5. That's okay. 4 plus 1 is 5. That one's good as well. So one of the ones that we saw in the previous video, we got 2 answers. One worked, one did not. In this scenario, we got that both answers worked. So both of those can occur as we are processing, okay? So now, we're going to revisit our compound interest formula because now we have a little bit more techniques to be able to solve. So the example, let me pull this back up so that you can see it real quick. So the example asks, how long to the nearest 10th of a year, so 1 decimal place, will it take $1,000 to grow to $3,600 at 8% annual interest compounded quarterly? So our A equals P parentheses 1 plus R over N to the NT is our formula. Remember that A is the amount that we're ending with, P is the principal or the amount that you put in, R is your rate in its decimal form, N is the number of compoundings, it is used twice in the formula, and T is time, generally in years. So we're going to put our 3,600 in there for A. We are going to put our 1,000 in there for P since that's what we're starting with. We've got our 0.08 because when we take that 8% and bump it back twice, that gives us 0.08. Divide by 4, and then we have 4t up there. So I'm going to bring this over to our whiteboard so that we can start doing a little bit of work with this. So the first thing I'm going to do is divide that 0.08 by 4 and go ahead and add it with the 1. Now, this is an exponential equation that we're going to need to solve. So the first thing is we're going to take off that 1,000 up there at the front because that exponent only goes with that 1.02. So I'm going to divide off the 1,000. Okay, that does divide fairly clean to just 3.6 when that comes down. Okay. At this point, you are going to need to take a log on both sides. I'm going to use natural log. Okay. I'm going to bring the 4t down in front of this side. And now I'm going to divide off everything that I don't need. Okay. So now, even if this problem had not said to approximate this to the nearest 10th of a year, this is a scenario where you're not going to walk up to somebody and say, hey, if you were to invest $1,000 at 8% compounded quarterly, and wanted to get it up to $3,600, you would need to invest it for natural log of 3.6 divided by 4 natural log of 1.02 years. It doesn't make sense to do that, okay? So we're going to look at this on a calculator, okay? Now, a couple little things. If you are using a grapher, you get to do alpha, y equals, and enter, and that will create a fraction for you. If not, you're just going to need to do a little bit of math for the top, some math for the bottom, and then go back and do the division. So I'm going to do my natural log of 3.6, and I'm going to close that. I'm going to move down to the bottom and do 4 natural log 1.02. Close that up. The calculator does know to keep those separated. So I get that that is going to take us 16.2 years, because again, it said to round to the nearest 10th of a year. So we have that. Now, this is great. The technique for this is really good if you are trying to figure out, hey, I want a college fund for my kid. I want to be able to buy something that costs this much money in some future time point. Retirement stuff. If you say I want to be able to have $500,000 at retirement, and I just want to put a lump sum in an account and let it sit, you are able to figure that out to decide whether or not, if I get, a $10,000 inheritance from my great uncle that passes away or something like that, will it grow in time? Because if it's going to take it something like 30 years, if I'm going to retire when I'm mid-60s, as long as I get that invested by say mid-30s, I can have that $500,000. But if it's going to take me 50 or 60 years, then I'm probably not going to be able to invest that in my mid-20s, mid-30s, and still be able to retire at mid-60s and have that money. So this is a really great technique to be able to know when you're going to, or how long it's going to take an investment. Now, this is considering that this is you drop the money in, you're not adding more money, you're not taking money away. This is just a straight, I'm putting $1,000 into an account and letting it sit, okay? And so after 16.2 years, you would have $3,600 at that 8% compounded quarterly.